Hey there, and welcome. Have you ever stopped to think about what everything around you is made of? I mean, from the bridge you cross on your way to school to the smartphone in your hand. Well, our world is literally built from stuff we pull out of the earth. Today, we're going to dig deep into minerals and energy resources. They're like the invisible foundation of your entire life.
All right, let's kick things off with a little riddle. What do your toothpaste, a light bulb, and a train all have in common? I know they seem totally random, right? But they all share a fundamental secret. Go on, take a guess before we jump to the next slide.
And there you have it. The answer is minerals. I know, kind of surprising, right? From the gritty stuff that cleans your teeth to the massive steel that makes up a train, minerals are the absolute foundation of, well, pretty much everything we build and use. They are, quite literally, everywhere.
All right, here's what we're going to cover today to get you all set for your exams. First, we'll look at minerals in your daily life. Then, we'll nail down what a mineral actually is. After that, we'll go on a hunt to see where they're found, sort them into a family tree, and then wrap up with a deep dive on one of the most important minerals out there, iron ore.
Okay, let's dive into that first point. We're going to start with something you definitely used this morning. We're going to look inside your toothpaste tube, and you'll be amazed to see how many different minerals it takes just to get that bright, clean smile.
Okay, check this out. It's kind of wild when you break it down. To actually clean your teeth, you've got abrasives like silica and limestone. That fluoride that helps prevent cavities, that comes from a mineral called fluorite. The reason your toothpaste is so white, that's titanium oxide. And hey, if it's got that little sparkle in it, you can thank mica for that. That's like 6 different minerals just to brush your teeth. Insane.
So, we've established that minerals are in everything. But what actually is a mineral, To answer that, we have to put on our geologist hats and get the real scientific definition. This part is super important, so let's focus in. All right, here it is, the official definition. Geologists define a mineral as a homogeneous, naturally occurring substance with a definable internal structure. Whoa, okay, that sounds a little textbooky, I know, but trust me, each part of that is actually pretty straightforward. Let's break it down.
So you've got to remember these 3 things. Homogeneous just means it's the same stuff all the way through. Naturally occurring is easy. It's made by nature, not by people in a lab. And probably the most important part, definable internal structure. All that means is that its atoms are arranged in a specific, repeating pattern, kind of like a crystal. That super organized structure is what makes a mineral, and not just some random rock.
Okay, so now we know what they are. The next big question is, where do we find them? They don't just pop up anywhere. It's kind of like a geological treasure hunt, and there are specific places to look.
So minerals can form in a bunch of different ways. You might find them in cracks inside igneous and metamorphic rocks. We call those veins and lodes. In sedimentary rocks, they form in big layers over millions of years. Sometimes they're just the tough stuff left behind after all the weaker rock around them is weathered away. They can even get washed down rivers and settle on valley floors. Those are called placer deposits. And get this, you can even find minerals dissolved in ocean water. Okay, so there are thousands of minerals out there. We definitely need a way to organize them all, right? So think of this next part as building the mineral family tree. Understanding this classification system is going to be a huge help for your exams because it tells us all about their properties and what we can use them for.
So this family tree basically has 3 big branches. First, you've got your metallic minerals. Think iron, copper, gold. Then you have the non-metallic minerals, like salt, mica, and limestone. And the third branch is the energy minerals. That's your coal, petroleum, and natural gas, the stuff that powers our world. For now, we're going to focus mainly on that first branch, the metallic ones.
Okay, let's zoom in on that metallic branch. There's a really important split you need to know. Ferrous versus non-ferrous. And it's actually super simple. Ferrous just means it has iron in it. Think iron ore, manganese. These are the backbone of the steel industry. Non-ferrous means, you guessed it, no iron. This includes stuff like copper, lead, and bauxite, which we use to make aluminum. They're valuable for totally different reasons, like being lightweight or great at conducting electricity.
All right, now it's time to put one of those ferrous minerals under the microscope. We're going to focus on iron ore, because honestly, if you understand iron ore, you understand the foundation of industrial development, especially in a country like India. This quote really just says it all, doesn't it? Iron ore is the basic mineral and the backbone of industrial development. Just think about that for a second. Without a ton of iron ore, you can't have a modern industrial economy. Period.
It is the literal starting point for everything from skyscrapers and bridges to cars and washing machines.
So in India, you'll mainly find two types of iron ore. First up is magnetite. This is the good stuff, the finest quality ore. It can be up to 70% pure iron and has these amazing magnetic qualities, which makes it really valuable for the electrical industry. The other major type is hematite. It has a little less iron, maybe 50–60%, but it's the one that gets used the most in industry. It's the real workhorse. So remember those two names, magnetite and hematite. They're key.
So where does all this iron ore actually come from? Well, this chart of India's production paints a really clear picture. You can see Odisha is the absolute giant here, producing about half of the country's entire supply. Then you have Chhattisgarh and Karnataka coming in next. These huge areas of production are known as the major iron ore belts. Wow! So we've gone from the tiny sparkle in your toothpaste all the way to the massive steel backbone of an entire country's industry. It really shows how minerals are, just like the source material says, an indispensable part of our lives. And that leaves me with one last thing for you to think about. What would one day, just one 24-hour day without any minerals, actually look like? No steel, no electricity, no glass. Really let that sink in. Now, if you want to dig even deeper into this and really get prepped for your exams, be sure to contact A1 Institute. They can help with admissions and they've got detailed notes and guidance. Their phone number's right there in the description. And hey, for more great explainers like this one, make sure you head over to the A1 Institute YouTube channel. Don't forget to like, share, comment, and subscribe. Thanks so much for watching.